Okay, guys, here we go. The probability of n given e is just 212 over 305. Never using, or I don't, never, whatever. It's 0.695, it's 0.70. I don't even care anymore. Part two, I'm finding the probability that you're in an environmental club given that you're not, whatever S is. S is an owner, I think. So if you're an owner, that's going to take you out. So we had to go with 212 and 77 in the top, and we had to go with these totals in the bottom to get our conditional probability. The third one's more interesting. Which one are you more likely? Well, you had to go find all of them. What's the probability you're in an environmental club if you've never owned a snowmobile? What's the probability you're in an environmental club if you have been an owner? And what's the probability that you're in an environmental club if you're a renter? Now, any of you who decided to just write your opinion without any math whatsoever and say if you've never owned a snowmobile, you're more likely, it just makes sense. And I know you're out there. You don't have to raise your hand. I know who you are. This is a question that's asking you math. Now, what the author's doing here is making it a common sense question so that the answers make sense to you. Later on, they're not all going to be common sense questions. So you should go out of your way on the common sense questions to do the math anyway. Find the probability that somebody is an environmental club given all of these options and see which is the biggest probability. In this scenario, the biggest probability, of course, is the people who have never owned snowmobiles. All right? Now, what happens if the given part doesn't matter? Let me go back to the earring thing and say that we're in a society where 80% of the girls in my class have earrings and 80% of the guys in my class also have earrings. Let's say that's the scenario. So when I go to ask the question, what's the probability somebody has an earring, and I say, given that it's the person I picked is male, it's not going to change the answer, is it? It's an 80% for all of you. It's an 80% if it's girls, and it's an 80% if it's guys. So in that scenario, the given part doesn't matter, right? Has no effect. So here we go. Two events, A and B. They're called independent. It's a word you've heard many times before. They're independent if the occurrence of one has no effect on the chance that the other will occur. Doesn't affect it at all, that means they're independent. Okay, so here's your notation. I can't stress how important this is because you're going to be asked later whether two things are independent. And again, just like this, don't just put what you think is a common sense answer. Use formulas, use math. I can't stress that enough to you guys. Look, I'm putting big ass asterisks, I'm putting stars, I'm telling you guys to stop with the common sense here and actually use a formula. Ready? If the probability of, I'm just going to write it down. I want you to just write that down and look at it. The probability of B given A equals the probability of B. What does that mean? Think about what that means for a second. All right, and I'm going to write another one. If the probability of A given B is equal to the probability of A. Write it and look at those for a second and think about what that means. Yeah, I know you don't know, but think about it anyway. What it means is A has nothing to do with B. If I'm given that A is true, and I go to find the probability of B with that knowledge, and it ends up just being the probability of B anyway, then A doesn't have any effect on B, does it? Then over here, if the probability of A knowing stuff about B is just the probability of A anyway, then B doesn't have any effect on A at all, right? So this means A doesn't have an effect on the probability of B. It doesn't have any effect on it. And then this is the same thing, but that B doesn't have an effect on A. If both of those are true, then they're definitely independent. They don't affect each other at all. All right, I'm going to have you guys read this example on gender and handedness, where they actually use the formulas to show that things are independent. I want you to do that on your own because you're too likely to just read things and go, yeah, it makes sense, they're independent, shrug your shoulders and get something wrong. So this uses these to show, and that's what you got to be good at in this class, to show that events are independent. So I'm not going to read it for you. I've read enough for you today. You read it and think about things independently on your own. See what I did there? Okay, so your homework is on page 348. You're going to do 61, 62, 65, 67, 69, and 70. Not on sapling today. They're out of the book. Your answers, I will make sure they're online or I'll get yelled at in a nasty email from one of you. All right, have a good day.